This is a second example on how to use the Euclidean algorithm to find the greatest common divisor. If you're trying to use the Euclidean algorithm to find a multiplicative inverse, then that's different, and see the link in the description for a video on how to do that instead. Alright, so this example, we want to compute the GCD of 12,345 and 11,111. We take the bigger number and put it out front here in green, and we say equals, and we take the smaller number and we put it right there, and we say multiplied times this, and then plus this. How we got those numbers is this divided by this equals 1 with a remainder of 1,234. So, we always want to have bigger number equals smaller number times something plus the remainder. And then we move on to our scooting process, where we take the blue position and move it over to the green position. And we take the remainder and we move it over to the blue position and do the same thing. Now, this number divided by this number equals 9 with a remainder of 5. It's very nice, makes our numbers much smaller. And then we do the same thing. Move the blue position over to the green position, and the remainder over to the blue position. So, 1,234 equals 5 times 246 plus 4. 4 being our remainder again. We do it again, take the 5, move it over to the green position, take the remainder, and move it over to the blue position. 5 divided by 4 is 1 with a remainder of 1. And then we do it again, move the blue over to the green, move the remainder over to the blue. 4 divided by 1 is 4 with a remainder of 0. And we know that the last non-zero remainder is the GCD. So this remainder is 0, the one before it, the remainder is not 0, and that is the GCD. So the GCD of 12,345 and 11,111 is 1. If you'd like another example, or a slightly more thorough example, see the first example I gave on this kind of thing, link in the description. If you have any questions, please post them in the comments below.